is a presentation on Nexus, which is a secure messaging application. This is a project for CIS 446. So to begin, we will go over the introduction. Firstly, the project overview. This is a secure messaging app featuring end-to-end encryption for private and real-time communication. The technology used in this application are .NET MAUI, Blazor Hybrid, ASP.NET Core Minimal API, SignalR, SQL Server, and .NET Cryptography. The main focus of the system is security, and we implemented hybrid encryption using RSA and AES with client-side key management with secured connection through HTTPS. The system architecture involves the four main components, which are client, backend, and database, and lastly the communication. Firstly, for the client side, it is built with .NET MAUI Blazor Hybrid, which is cross-platform, meaning a single application can work on multiple platforms. The client manages UI logic, cryptographic operations, and real-time communication via SignalR, which is a library. The backend is built with ASP.NET Core Minimal API, which handles authentication, message logic, and SignalR hub functionality. The database is built with SQL Server, which stores encrypted messages, user metadata, and conversation logs. It provides access to the backend through stored procedures. For communication, the application uses HTTPS for API calls. It uses WebSockets for real-time messages via SignalR. Some of the core features of the software are secure registration and login. The client-side cryptographic key generation ensures no private key ever leaves the device. So basically, whenever the user is logging in or registering, the key gets generated in the client side, and only the public key gets sent to the database so that other user can encrypt messages with that key. Contact management is basically the user can search and add new contacts to their conversation, or the existing conversation that they had. Those contacts will show up on their dashboard. Encrypted one-on-one chats. The messages are encrypted end-to-end using hybrid RSA and AES encryption, which I will go over in a bit. And lastly, protected API calls. The software uses JWT token for general operation of the software. The only publicly available APIs are the login and registration, but the other APIs are protected with token, and those are an user authentication to verify user credentials. For end-to-end encryption, the main objective is privacy, that we ensure that only sender and intended recipient can decrypt message content. The encryption method utilizes hybrid encryption model using RSA for key exchange and AES for message content. The session-based keys for the client generates RSA key pairs per login, and private key stays on the device itself, as I discussed before. The public key gets shared with the backend, and the backend then stores that in the database, and whenever there is a new contact or somebody wants to message that user, they will retrieve that public key from the database. So here is a simple walkthrough of how the key or the RSA key gets generated. So when user A first registers or logs in, their device generates a RSA key pair for them. The private key is stored on their device, but the public key is ready to share, and then when they click register, along with all their username, password, first name, last name, and everything like that, the public key gets sent to the backend server. The backend stores that public key into the database, and it can be now fetched by any other users. So let's say user B retrieves the contacts, or let's say searches for that user, they will receive that user's information, including like first name, last name, and the public key, and their device will cache that into their system locally, so that they can like encrypt messages with that public key. And lastly, when the user logs out, we just simply delete that RSA key pair from the device for security measures. So now after logging in, the user basically has the recipients or the person they want to contact, their public key. So whenever they are sending a new message, we generate a new AES key with the K and then the initialization vector IV, and after that we will encrypt that plain text message with the AES key, and then initialization vector IV, and then we get the encrypted content, which was the plain text initially, but it's encrypted with AES now. And after that we have the K for the AES key, but we encrypt that K with the public key of the recipient, since we initially got that from fetching from the backend. So then we get the encrypted key, which can be only decrypted with the private key of the recipient, and no one has that. So lastly, we just send that all those content to the database, basically to the backend. The backend receives the encrypted content, the encrypted key, initialization vector, and some other stuff like conversation ID and send time. The server storage will store those data into the database. Even if someone intercepts it, it's the server, and they can't decrypt that message because no one has that private key except for the owner. So it remains confidential, and it can be only decrypted by the recipient's device. Now, when the recipient logs into the system, or let's say they were in the conversation and the SignalR basically broadcasted that message, they will receive that encrypted message with the fetch or SignalR, and then they will get all those information that were saved in the database. And then after that, using their private key, they will decrypt that AES key. So after they decrypt the AES key with their private key, they will then decrypt the encrypted content of the message with the decrypted AES key and the initialization vector, which will then give them the plain text, and the system will then render that message into their UI. So now we will demonstrate how the software works. So this is the Android emulator for the Android version of the application. This is the Windows app. So first, for this account, we can simply log in. As you can see, there are some error handlings. So we're logged in. They have some contacts. I can search for new contacts as well, like call, and this is a new contact, but here are the old ones. For this account, we will log in. So we can say, let's do Sarah. Main. So we are logged in, and now we can find this user. So to find them, we can just simply search anything related to them, and we can start texting them. As you can see, we can enter other users as well right here, but since we logged in again on this version of the app, we don't have access to the old RSC private key, so we can't decrypt these messages anymore. So if we go back, we see that Sarah Lane is here already for the contacts, so we can enter here and then we can start chatting. The messages are showing up now. As you can see, everything's working as anticipated. We can also show some other features. So this is how SignalR is being operated. So whenever I send a message, it is being broadcasted with the conversation ID, and whoever is connected with that ID, they will receive that message, and that's why this user is getting that messages. And for the database version, all the data is being stored with its encrypted version from the moment it leaves the sender side until it gets to the recipient side. It's always encrypted. The content are encrypted as well as the AES key. The IV is there as well. And also we are only providing the backend the access they need instead of giving them the entire access. So for example, to get the messages history, we only allow them to get history for the conversation ID that they need instead of giving them access to the whole entire database table. This approach allows for a secure way to ensure that data integrity is maintained. So here are some other stored procedures. This is the front-end application. So this is the main app, this is the shared version, and this is the web and the client. Because of the MAUI and Blazor hybrid data structures, we can utilize the shared project type and use all the Razor pages here, and that will compile into all the other project types, and we can use the Windows app as well as the Android version of the application to build the multi-platform application. And as I showed before, the backend is also built with C#, but it's with the ASP.NET Core Minimal API. We have the data repository here. This is a chat hub. It just basically utilizes all the methods that's from the hub parent class, and it's protected by the authorization. But this is for the SignalR. And these are the API endpoints basically. And that's it.